Hey guys, today we are going to be looking at Beer-Lambert's law and a rate law, and we are going to be doing the rate of reaction of the fading of crystal violet. So go ahead and pause the video and take just a minute to look at these learning targets. So in this lab, we're going to be looking at crystal violet. So when you look at crystal violet, we are going to write it with that CV that you see right there. And the reason that we're doing that is because it's way too long to write out every time. And when we are fading crystal violet, the way we'll do it is we'll do it by adding sodium hydroxide. So this will be the ions that come from our sodium hydroxide. And then, of course, this will be our product. So what we'll do is we are going to put this in a spectrophotometer, and we are going to look at the rate of absorbance from 0 to 600 seconds, and we are going to go ahead and collect that data. So the rate law, if you look at this, if we are trying to find the rate law of this reaction here, the disappearance of our reactants, the rate law would then be our K. Let me erase this real quick so we can look at it better. So it will be K times the concentration of CV, and that will be 2Rm, times the concentration of OH, and that'll be to the power of N. So what we're going to do is we actually are going to know the concentrations of our CV and our OH. And what we really want to find out here is what the concentrations are. I'm sorry, what is M, what is N, and what is K. And that's what we're going to be solving for. So the concentration of our CV is going to change over time, but our OH is going to stay the same because we're going to add enough OH that the change in OH isn't going to matter at all. It's not going to be affecting the reaction at all. All right, so what we're going to do in order to get all of our data is we're going to use a spectrophotometer to measure how much light is being absorbed. So the first thing we'll do is we'll get this little cuvette, and it's this little square thing. All right, and what we'll do is we are going to pour in some crystal violet, and we are going to pour in some sodium hydroxide. And we'll pour enough in, and what we will do is we'll put it in the spectrophotometer, and it's going to shoot some light at the solution. And what that's going to do is it's going to measure the absorbance. So how much light is going to be absorbed in this solution. So the darker it is, of course, the less light is going to be absorbed. So what we'll do is we will plot absorbance over time. So the darker it is, then the lower the number will be, and the higher it is, the lighter it is, the higher number will be because it'll absorb more light. And we'll collect that data over time. And when we do that, we'll get, we'll graph that and see what our rate constant is. So we'll see what is our, the change in molarity over time, because we're going to see the concentration change, and we'll have absorbance versus time. Okay, and then what we're going to do is we're going to go ahead and look at Beer's law. So to look at Beer's law, and I'm sure you remember, I'm sure some of you guys looked up Beer's law, and Beer's law, it's called Beer-Lambert's law or Beer's law, what we sometimes call it. It's A times B times C. Okay, so C is really the one we're going to solve for. C is our concentration. And that is the concentration, and what we're going to be solving for is the concentration of our crystal violet. And then we are also going to look at our other letters here. So B here, B is going to be our wavelength, and that is how far, I'm going to spell it. This is how far our the light has to travel through. So that's the width of our cuvette, and generally that's going to be about 1 millimeter that the light, 10 millimeters, 1 centimeter that the light has to travel through. Okay, and then we have A. A is our molar absorbed, I can't say it right. Okay, this is actually a constant for each individual molecule. So every different compound, molecule, atom, ion has its own molar absorptivity coefficient, and I will give that to you when we do the lab. This is unique to each compound, so that is something that we are going to know when we get to the lab. And then, of course, we have the big A at the front here. Okay, and this, can I get my pen to work? This big A right here, this is our absorbance, And this is actually what we're going to measure in the lab. So we'll measure this, we'll know this, and this here is what we are going to solve for. So we will be able to solve for what our concentration is over time. One thing that you will need to do in the lab is something that is a little bit different than you've done before. Usually I do all of your pre-lab work for you, but what I want you to do is actually dilute the solution yourself. Okay, so what you're given when you get your crystal violet, we have this teeny tiny little like dropper bottle of crystal violet solution, and it's very concentrated. So what you're going to need to do is do your own dilutions. So in order to do dilution, you're going to use the formula M1V1 equals M2V2. Okay, so I'll just give you a quick example. So say you have a 250 micromolar solution and you want to get a 10 molar solution out of that. So this will be your M1. We want to know how much do we need to add in order to get a 10 molar solution. And I want to end up, let's say, just for fun, I want to get a 10 milliliter solution total. That's how much I want. So my M2, I want to end up, I just said, with a 10 molar solution. And I want to have a total of 10 milliliters. So once I do the calculations and solve for V1, my V1 is going to be equal to 0.4 milliliters. So this is how much crystal I want to put in there, crystal violet I want to put in. But remember, I said that my total volume needs to be 10 milliliters. So what I want to do is add 9.6 milliliters of water to that. So make sure when you are doing your pre-lab, you all need to make sure that you go through the pre-lab, read the entire pre-lab, answer the pre-lab questions. There is an area where you need to do a chart that shows you how to do all of the calculations for this. This is the way you do the calculation right here, and you need to fill out the chart so that you know how to do the calculations for all of the concentration, because each different group is going to make their own molarity of this crystal violet, because I want each of you to test a different molarity of crystal violet when we do this in the spectrophotometer tomorrow. So let me know if you have any questions. You can email me if you have any questions, and when we get to class tomorrow, we can go ahead and get started right away. Hope y'all enjoy.